Hi everyone, this is Abhay Mahajan, and in this session we are going to discuss UGA 2023 ISI solutions. So let us get started without any delay. So this paper overall was, I would say on the simpler side. UGA portion was on the simpler side as compared to the last year, and there were hardly 2 to 3 questions which could have troubled students, and apart from that a lot of questions were direct. So let us get started and do these questions. So these were the general instructions which are given, right? So R is a set of real numbers, C is a set of complex numbers, this symbol n upon R with this bracket is NCR, n factorial by R factorial n minus R factorial, right? So this is the usual instructions which are given. So let us get started with the problems. This is the first problem. X cube minus 7x plus 6 is positive if and only. So this is a simple question on inequality. We can directly see if fx is x cube minus 7x plus 6. So clearly f of 1 is 0, indicating x cube minus 7x plus 6 as a factor x minus 1. The other factor can be, found by dividing this. So it will be x square minus x square. So it will be plus x minus 6. And this can further be factorized. So again, this can be written as x minus 1, x plus 3, x minus 2, and the question is, when is this greater than 0? Right, so this can be easily found using Vevika. So this was a very simple question in that regards. So minus 3, 1, 2, plus, minus, plus, minus, so positive. So the complete solution is going to be minus 3 to minus 1, union 2 to infinity. So minus 3 to minus 1, union 3 to infinity would mean this is option D. So option D was the right answer to this question. I hope this is clear. And I'm very sure the students who are attempting this would have done this question correctly, because this was a very simple paper question to begin with. The number of consecutive zeros adjacent to the digit in units place. So again, we are very sure 401 to the power 50 is going to end with 1. The unit digit is going to be 1, which we are very clear about it. Now, as per this question, there are certain number of zeros before 1, right? So there may be 3 zeros, there may be 4 zeros, there may be 49 zeros, there may be 50 zeros. So which of these? So basically, how many zeros are there before the last digit? Before the last digit, how many continuous zeros are there? This is the question, right? So again, this is a very standard application of binomial theorem. 401 to the power 50 can be written as 400 plus 1 to the power 50, and this can be expanded. So it will be 50C0 400 to the power 50, right, plus 50C1 400 to the power 49, 50C2 400 to the power 48. Second last term would be 50C48 400 square. Third last term, 50C49 400 plus 50C50, right? So this is how it is expanded, right? Of course, this term is 1. Let us look at this term. So this is actually 50 into 400. That means 20,000. So second last term is 20,000. Second last term being 20,000. Let us look at the third last term. The third last term would be 50 into 49 by 2, that is 50C2 into 400,400. So this means this is the term which ends with at least 4 zeros or 5 zeros. So this is going to end with, 4 zeros. 4 zeros. So 0, 0, 0, 0, maybe something here. And all the other terms apart from this, all the previous terms, so this would be having 400 cube. 400 cube would means at least 6 zeros. At least 6 zeros. 400 to the power 4 means at least 8 zeros. So all the other terms apart from this are going to end with at least more than 4. Right? So whatever this term is, I need to make sure that this term is not 8. This is not 8. So we can actually calculate this. So 25 into 49 into 4 into 4. So 25 into 49 into 4 into 4. So this is, I mean, this is also going to be 0. Right, so 0, 0, 0, 0, for 25 into 4 is another 0. This is another 0, so this is again 0. So all the other terms apart, before this also are going to end with zeros. So can I say, this term is going to be 2, 0, 0, 0, 1. I am not concerned about what is there. Basically, before 1, there are 3 number of zeros. Option A is going to be right. Right, so this was the most simple application of binomial theorem, and if you knew binomial, you should have done this particular question. So option A is the right answer to this. Option C, so this, question number 3, geometry. Consider a right triangle ABC. So this is a right triangle ABC, whose hypotenuse is AC. So this is A, this is B, this is C. The bisector ACB. So we are drawing the angle bisector ABC. Intersects AB at point D. Right? Whose hypotenuse AC of length 1. So this is length 1. The bisector angle ACB intersects BC is of X. This is length X. So these are lengths 1X. What is the length of CD? Length of the angle bisector. Length of the angle bisector is what you need to find. So one is you can directly, write the formula for the angle bisector. Right? So angle bisector length is this into this minus this into this under root. So root of this into this length minus this into this, and this can be found out because this length overall is root of 1 minus x square. This length is root of 1 minus x square by Pythagoras theorem. So if this AD upon DB is equal to 1 upon x using the angle bisector theorem, so angle bisector divides the opposite side in the same ratio as the length of the other two sides. So you can find out the length AD, you can find out the length BD, and of course you can directly find the formula. But otherwise also this was very simple because this was a right triangle which is given to us. So we can always apply Pythagoras here because BD, length BD, so this ratio is 1 by x and whole AB length is root of 1 minus x square. So DB length is going to be equal to x upon x plus 1 into root of 1 minus x square. Right, so this is going to be DB. So ratio is going to be x upon x plus 1. So ratio is x upon x is to 1. Total length is this. So x upon x plus 1 times this is going to be length DB. DB आ गया, BC आ गया, I think CD का length आ जाएगा using Pythagoras. So CD square is equal to x square plus BD square. BD square is this. So x square upon x plus 1 whole square into 1 minus x square is 1 plus x into 1 minus x. So एक तो cancel हो गया. So CD square x square common ले लिया. X square upon x plus 1. So यहाँ पर x plus 1 बचा, यहाँ पर 1 minus x बचा upon x plus 1 बचा. So this goes. So CD square is equal to 2x square upon x plus 1. So CD is going to be root of 2x, or okay, directly it is given. So option A is going to be the right answer to this. Right, so this is a very simple question. Again, if you didn't know what the length of the angle bisector is, you could always find this out using Pythagoras theorem because the fact that it is a right triangle, it made it very simple. Okay, so this was again a very straight question. I hope this is clear. Okay, define a polynomial by this. X belongs to real where right hand side above is the determinant, then the roots of fx is of the form. So again guys, this is NCERT kind of question, right? So as I told, there were very less questions in the whole exam which could trouble, maybe 2 or 3 questions which could actually trouble someone who's prepared for this particular exam. Otherwise most of the questions were very easy. Right, so what do? The standard is add everything up row wise or column wise. So again we can do R1 goes to R1 plus R2 plus R3. So basically 1 plus x plus x, 1 plus x plus x, 1 plus x plus x. So 2x plus 1 can be taken out. So fx is equal to 2x plus 1 into determinant of 1, 1, 1, x1, x, x, x1. And then maybe we can make 2 zeros और अपने आप आंसर आ जाएगा. तो यहाँ पर अब what you can do is C1 goes to C1 minus C2 and C2 to C2 minus C3. So fx is equal to 2x plus 1 times determinant 0, 0, 1. X minus 1, 1 minus x, x. 0, x minus 1, 1. So if you open by the first column, first row, it is going to be 1 into x minus 1 whole square. So fx is going to be 2x plus 1 into x minus 1 whole square. So the question is the roots of fx. So of course the roots are minus 1 by 2, 1 and 1. So two of the roots are same, one is different, but the important thing is all the roots are real. So of course this is not going to, so this is going to be the answer. Alpha beta are the real and distinct. Right, so option B is the right answer, and this is NCERT. This is NCERT stuff because NCERT, a lot of questions are there. Prove that this is equal to this, right? So this is how we do it, right? The only thing is, the idea was to, save time on these kind of questions. You could do this very quickly. You can do these questions very quickly. You have to save time in these kind of questions and put this time judiciously in those good questions. Okay, this was again very straightforward. So this is actually an identity. Right hand side is going to be coming, will come out to be equal to left hand side. Let's see how. Clearly this is a GP, an infinite GP. So this is cos square x, cos cube x, cos to the power 4x and so on up to infinity. And clearly this is a GP whose common ratio is cos x, which is less than 1, whose the value is between minus 1 to 1. So this is, we can apply the formula for infinite GP, cos square x upon 1 minus cos x. Right. So what we can do here is, we can multiply and divide by 1 plus cos x, left hand side. We are only approaching left hand side. So this is cos square x into 1 plus cos x upon 1 minus cos square x, which is sin square x. So this is 1 plus cos x into cot square x. So clearly this shows that left hand side is always equal to right hand side. The only thing is you need to be ensuring that this is always defined. This is always defined. So left hand side we have cos x, right? So don't think about this expression because this expression is the formula application of this. The original expression is this. Cos x is always defined. Even if cos x is 1 or minus 1 or 0, cos x is always defined. So left hand side is always defined. The only problem is right hand side. Right hand side we are given cot x. This is always defined. We are given cot x. So cot x is cos upon sin. Cos square x upon sin square x. And again, clearly this is not 0. Sin x is not 0. This is the only condition because if sin x is 0, right hand side is not going to be defined. As simple as that. So the only condition is since this is an identity, this is always going to be holding true apart from the conditions that all the things in the given condition, given equation should be defined. So here sin x is the only problem. So sin x should not be 0. Sin x should not be 0, that is x is not equal to n pi. This is the only thing we had to note. So x belongs to all real, x is not equal to n pi, so option B is going to be the correct answer to this. So this was again a very simple. So far every question that we have done is very simple and this was a very simple paper. Okay, now S is given to be a set. It is an ordered pair of this kind where theta belongs to R and theta is positive. And T is an ordered pair, x and y are real and xy is equal to 2. How many elements does T intersection F have? So basically it is saying how many values of theta positive are going to satisfy this equation. This is x, this is y, and we need to make sure that x into y is 2. So let us multiply. So if you multiply this, theta and theta goes. So we have sine pi theta upon 1 plus theta cos pi theta upon 1 plus theta is equal to 1 by 2. This is the only thing we need to make sure. For how many thetas does this hold true? So that means 2 into this is 1. So sine 2 pi theta upon 1 plus theta is equal to 1. Now the important thing is the range of theta is given to us. The range of theta is positive. Theta is positive. So 2 pi theta upon 1 plus theta. Now guys, यहाँ पर बहुत ही सिंपल सा चीज जो तुम्हें देखना था दैट इज कि थीटा अगर पॉजिटिव है तो ये जो रेंज है ये कितना है, ये कितना है. सो थीटा अपॉन 1 प्लस थीटा देखो, थीटा अपॉन 1 प्लस थीटा, ठीक है. अगर थीटा पॉजिटिव है, इफ थीटा इज पॉजिटिव, अगर ऊपर भी पॉजिटिव है नीचे पॉजिटिव है तो कहने से नीचे वाली चीज ऊपर से हमेशा बड़ी है, ठीक है. तो डेफिनेटली ये 1 से छोटा रहेगा. लिमिटिंग वैल्यू थीटा इन्फिनिटी पे देखो, यहाँ पे थीटा अगर इन्फिनिटी कर देंगे तो 1 upon theta plus 1 ये 1 हो जाएगा. लिमिटिंग वैल्यू इज 1 एंड मिनिमम वैल्यू इज 0. क्लियरली थीटा इज ग्रेटर देन 0. सो थीटा अपॉन 1 प्लस थीटा बिलोंग्स टू 0 to 1. दिस इज वन थिंग विच हैड. अगर ये आ गया 2 पाई से मल्टीप्लाई कर, दोनों को 2 पाई से मल्टीप्लाई कर दो, तो दिस इंटू 2 पाई, 2 पाई, 2 पाई. So that means 0 less than 2 pi theta upon 1 plus theta less than 2 pi. तो यार ये जो एंगल है ना, दिस एंगल, ये जो एंगल है ये 0 से 2 पाई के बीच में है. और सोच के बताओ, साइन ऑफ एन एंगल इज 1 और वो एंगल 0 से 2 पाई के बीच में है. वो एंगल 0 से 2 पाई के बीच में. सो 0 से 2 पाई द ग्राफ लुक्स लाइक दिस. इसको मान लो ना, y मान लो. लेट्स से दिस इज y. तो साइन y 1 सिर्फ एक ही वैल्यू पे होगा जब ये वाली वैल्यू पाई बाय 2 की. दैट इज 2 पाई थीटा अपॉन 1 प्लस थीटा का वैल्यू पाई बाय 2. इससे कॉरेस्पॉन्डिंग थीटा आएगा ही आएगा और एक ही थीटा आएगा. There is always going to be what theta, which so 4 theta is 1 plus theta, giving us theta is 1 by 3. Theta 1 by 3, तो एक ही वैल्यू आएगी. How many elements? एक ही. So there is only going to be one element, that is theta is equal to 1 by 3, जो कि मैं यहाँ पुट करूंगा. This into this is going to give me half. Otherwise कभी भी half नहीं आएगा. So exactly इन दोनों का intersection is exactly 1. So this was again on the simpler side. The only thing is, आर यू एबल टू आइडेंटिफाई. पहले तो बहुत सारे बच्चों को क्वेश्चन समझ नहीं आता देखने में कि हो क्या रहा है. सो अगेन टी इज एन ऑर्डर्ड पेयर, एस इज ऑल्सो एन ऑर्डर्ड पेयर. टी के बारे में दिया हुआ है एक्स इंटू वाई इज हाफ, मतलब द प्रोडक्ट ऑर्डर्ड पेयर ऑफ दिस, द प्रोडक्ट ऑफ दिस ऑर्डर्ड पेयर इज हाफ. हमें बताना है कि ऐसा कोई थीटा एग्जिस्ट करता है 0 से बड़ा सच दैट इन दोनों का प्रोडक्ट हाफ है. दैट इज द ओनली क्वेश्चन, राइट. सो देयर इज ओनली वन आंसर, दैट इज थीटा इज इक्वल टू 1 by 3. आई होप दिस इज क्लियर. How many numbers formed by rearranging the digits of 2, 3, 4, 5, 7, 8 are divisible by 55? So 55 is clearly 5 into 11. So let these numbers be A, B, C, D, E, F. Clearly F is 5 because the number is divisible by 5. The last digit has to be either 0 or 5. 0 is not there. Last में 5 आएगा, ये तो पक्का है. ये तो पक्का है, ठीक है. अब यहां पर देखो डिविजिबिलिटी बाय 11 भी इंश्योर करनी है. तो यही क्वेश्चन है कि यार ऐसे कितने ए बी सी डी ई एफ के कॉम्बिनेशंस होंगे सो दैट दिस नंबर इज आल्सो डिविजिबल बाय 11 बिकॉज़ वी हैव इंश्योर्ड द डिविजिबिलिटी ऑफ 5. 5 का डिविजिबिलिटी इंश्योर कर लिया, 11 का करना है. दिस इज द थिंग. एंड हाउ डू वी इंश्योर द डिविजिबिलिटी बाय 11? ऑल्टरनेट सम. सो बेसिकली a minus b plus c minus d plus e minus 5 should be 11k. So अगर ये 11k है, अगर ये 11k है, k can be 0, positive, negative, then this number is divisible by 11. Right? So let us ensure कि 11k होता है या कब होता है. तो यहां पर ना मैं क्या करता हूं, a plus c plus e अलग कर देता हूं, b plus d plus 5 अलग कर देता हूं. This is 11k. b plus d plus 5 अलग कर दिया, 11k. a plus c plus e को ना थोड़ी देर के लिए x मान लिया, इसको y मान लिया. Right? So basically what I'm doing is x is a plus c plus e and y is b plus d plus e. So as per this x minus y is equal to 11k. 11k मतलब क्या क्या हो सकता है? It can be 0, 11 minus 11, 22 minus 22, 33 minus 33, 44 minus 44 and so on. बहुत लॉजिकली हम ये डिड्यूस कर सकते हैं कि यार ये 11 माइनस 11 0 के अलावा ये वैल्यूज हो ही नहीं सकती. बिकॉज अगर सोच के देखो 22 का मतलब क्या है? 22 का मतलब क्या है? इनमें से कोई 3 टर्म का सम माइनस 3 अदर टर्म्स का सम 22 है. देखो अच्छा, x प्लस वाई देखते हैं. व्हाट इज x प्लस वाई? x प्लस वाई इज अ कांस्टेंट. x प्लस वाई मींस इन सब का एडिशन, a प्लस b प्लस c प्लस d प्लस e प्लस 5, बेसिकली इन सब का एडिशन. तो 15 प्लस 5 20, 24, 27, 29. सो दिस इज 29. दिस इज 29. ठीक है. अब सोच के देखते हैं x माइनस वाई का व्हाट इज द मैक्सिमम वैल्यू. x माइनस वाई मैक्सिमम वैल्यू कितना हो सकता है? लेट अस फाइंड दिस. व्हाट कैन बी x माइनस वाई मैक्सिमम? सो x वाई माइनस वाई मैक्सिमम मीन्स मुझे अगर करना है तो आई नीड टू एंश्योर x मैक्सिमम एंड y मिनिमम. दिस इज व्हाट x मैक्सिमम के लिए क्या करो यार, इन सब का एडिशन कर दो. 8, 7, 5, 15, 20 माइनस इन सब का एडिशन इज 9. सो x मैक्सिमम कैन बी 11. सो it cannot be this, it cannot be this, it cannot be this. Similarly, x minus y minimum is minus 11. Right? So x minus y can only be 0, 11, minus 11. Right? So we have x minus y is 0, 11 or minus 11. X plus y is 29. Now clearly we can't have even 0. Because if sum of two numbers is 29, they should have the same parity. x plus y और x minus y का parity same होगा. So x plus y अगर odd है तो x minus y भी odd होगा, तो 0 वैसे नहीं हो सकता. अगर 0 करते हो भी हो, x will not come out to be integer. So let us look at this case. Add करते हैं first case में. So 2x का value कितना आएगा 40 and second case में 29 minus 11 is going to be 18. So x का value first case में 20 हो जाएगा, the second case में 9 हो जाएगा. y का value फर्स्ट केस में 9 हो जाएगा, सेकेंड केस में 20 हो जाएगा. ठीक है, y था b प्लस डी प्लस 5, b प्लस डी प्लस 5. अच्छा, y का वैल्यू कैन बी दिस बी 9. लेट अस सी, y का वैल्यू 9. ठीक है, तो बेसिकली एक x का वैल्यू 20 एंड y का वैल्यू 9 एंड दूसरा ऑर्डर पेयर क्या हो जाएगा 9, 20. आई एम लुकिंग एट दिस ऑर्डर पेयर कि x 20 y 9. अगर y 9 है, if y is 9, that means b plus d is 4. Out of these numbers, can there be two numbers who add up to 4? अगर b plus d 4 है, b plus d 4 हो नहीं सकता. किन्हीं भी दो नंबर्स का सम 4 नहीं हो सकता, तो this goes. y cannot be 9. This result, this possibility also goes. इसका मतलब the only possibility is y is 20, x is 9. The only possibility left is y is 20 and x is 9. Now guys, if y is 20, y 20 मतलब b plus d plus 5, b plus d plus 5 20, that means b plus d is 15. दो नंबर्स का 15 एक ही तरीके से सकता है 7 और 8. 7 और 8. इसका मतलब d और e जो है ना वो 7 और 8 है in some order. Sorry, not d and e, b and d. b and d. B and D are 7 or 8 in some order. So 7, 8, 5 हो गया. इसका मतलब ACE are 2, 3, 4 in some order. ठीक है, तो लास्ट नंबर तो 5 है. B और D are 7 or 8 in some order. ACE are 2, 3 or 4 in some order. So basically 2, 3 and 4 can be rearranged in 3 factorial ways. And B and D can be rearranged in 2 factorial ways. So 6 into 2, 12. So 12 is the right answer. So 12 is the right answer to this. Question number 7. The answer is B, Bombay. That is 12. Right. So this was the question which could have troubled some of the students a bit. Otherwise also this was very simple, very straightforward because there was only one case to be considered. So if someone hits this case first of all, he will be able to arrive the answer very quickly. If someone tries hit and tell also, then also he will be able to do it very quickly. Right. So this was the only case to be considered and this was the only case that came. 3 factorial, 2 factorial, B is the right answer. I hope this is clear. Question number 8. Oh, this was a good question, guys. This was a good question. This is one of those questions, one of those 30 questions which I am saying would have troubled some of the students, right? So again, clearly by looking at it, it seems that it is a question of sum of limits, right? So integration using sum of limits. So that is the question, right? But again, if we remember, how do we use this? How do we use this? So integration sum of limits, we have to make this form. We have to make this form f of r by n into 1 by n. Sigma f of r by n into 1 by n. So clearly एक चीज तो clear है कि मुझे log देना पड़ेगा ताकि ये multiplication turns into product. So these are standard questions that we discuss in the class also. So we have to take log on both the sides so that this multiplication gets converted into addition. Very important, very obvious, right? So that is one. The other thing is, ठीक है? The other thing is r by n भी बनाना है. अगर हम यहाँ पर ध्यान से देखें, this is n plus r raised to the power n plus r. I do not want this. I want r by n. R by n. So what I can do is यहाँ पर 1 by n square है. ये एक n बाहर सबके. So basically what I'll do is let's say p is limit n approaches infinity n to the power minus 3 by 2. So we have n plus 1 raised to the power 1 upon n I give to every power. So it will be n plus 1 by n, that is 1 plus 1 by n into n plus 2 raised to the power 1 plus 2 by n. N plus 3 raised to the power 1 plus 3 by n. and so on. And last term would be n plus n raised to the power n, or raised to the power 1 plus n by n. Right, so I'll use the yellow marker only. 1 plus n by n raised to the power 1 by n. So basically we had two n's overall, 1 upon n square. 1 n I gave it to every power. Right. So this is sorted, 1 plus r by n, 1 plus 2 by n, 1 plus. Now I also need 1 plus r by n in the denominator. So what I do is, I divide every term by n. So basically I do n here, I do n here, I do n here, of course I do n here. So of course n to the certain power gets multiplied also. So what is that certain power? What is that certain power? So basically what I am going to multiply this with is n to the power 1 plus 1 by n plus 1 plus 2 by n plus 1 plus 3 by n and so on up to 1 plus n by n. So there are n brackets. So n to the power n plus n into n plus 1 by 2 n. So n to the power n plus n plus 1 by 2. So it is going to get multiplied by this also. Are you getting this? It is going to get multiplied by this also. Right? So we have, so n to the power this number. Let's say I call it k. N to the power k. Right? So if you want to, simplify this, you can simplify this also. I was hoping that this, goes away, but it is not going away. Right? So basically what you did was you divided this by n and multiplied n with the same number. So n power is going to be, so basically you divided n by this power in the denominator. So you're going to multiply n with the same number. So n to the power this. Okay. So let us move on to the next slide. So we have p is equal to limit n approaches infinity, n to the power minus 3 by 2 into. Now this n to the power k by n. Okay, first of all, it will be k by, so what I can do here is, because I already multiplied by n, so n has to be multiplied here also. So what I'll do is, it will be this, n to the power k by n square. Now this is correct. And k is this. So what is k by n square? Let me calculate k by n square. So k by n square. So k is, let us calculate k. So k is 3n plus 1 by 2. So k by n square. K by n square. Right, so one second. No, it will be k by n only. It will be k by n only because anyways I have already, it will be k by n. N to the power k by n. It will be n to the power k by n, and k by n is going to be 3n plus 1 by 2n. 2n. So that is 3 by 2 plus 1 by 2n. Right, so let us look at what is happening before. So n to the power 3 by 2 plus 1 by 2n into n to the power minus 3 by 2. So n to the power 1 by 2n is going to be left. N to the power 1 by 2n is left. Right, so this is going to be n to the power 1 by 2n into, now this is in the desired form, 1 plus 1 by n, 1 plus 1 by n raised to the power 1 plus 1 by n, 1 plus 2 by n raised to the power 1 plus 2 by n, 1 plus 3 by n raised to the power 1 plus 3 by n, multiplication 1 plus n by n raised to the power 1 plus n by n, raised to the power 1 upon n. Now to convert this into sigma, we'll take log on both the sides. So log p, limit n approaches infinity. So this is 1 upon 2n log n plus 1 upon n. This is sigma 1 plus r upon n log 1 plus r upon n. R varies from 1 to n. R varies from 1 to n. Right? Now let us try to calculate both of these terms. So first of all, this term, this is infinity by infinity form. Log n by n, infinity by infinity form, and limit n approaches infinity. Log n by n or 2n. 2n is infinity by infinity, so we can apply LH rule. So this is 2, this is 0. So this is 0 clearly. The first part is 0, right? And second part can obviously be converted into integration. So 0 to 1, 1 by n is dx. So this is 1 plus x log 1 plus x. And this is 1 to 2 t log t dt. 1 plus x को t पुट कर दो तो लिमिट चेंज हो जाएंगी. अब तो अब कुछ बचा ही नहीं है, तो log t into t square by 2 minus integration of t square by 2t. So log t into t square by 2 minus 1 by 2, t का integration is t square by 2. So t square by 4 from 1 to 2. So let us put the values. So it will be 2 log 2 minus 0 minus 1 by 4 into 3. ये आ गया. This is log p. Log p. So clearly, अब तो clearly answer हमें दिख भी रहा है यहाँ से. So we have log p is equal to log 4 minus 3 by 4. So can I say log of p by 4 is equal to minus 3 by 4? So p by 4 is equal to e to the power minus 3 by 4 and p is equal to 4 e to the power minus 3 by 4, which is option D. So option D is the clear answer to this. So as discussed, this was the only question. ये इकलौता question है जो बच्चों को disturb किया होगा, जो तकलीफ दिया होगा. Otherwise, apart from this, there were two, three more questions जो हम आगे discuss करेंगे. And apart from those, I think most of the paper was easy again. But इस paper में भी, easy paper में भी, it is very difficult to score, to your full capacity. A lot of students make mistake because it is a high pressure day, right? So that was the only thing. Apart from that, there was nothing substantial about the questions that we are discussing here. This is one of the easiest questions. Consider a triangle with vertices 0, 0. So again, if you draw the triangle, you'll know it's a very good triangle. 0, 0. There is a point 1, 2. एक point है 1, 2. 1, 2. एक point है 1, 2. And there is another point minus 4, 2. So minus 4, 2 is going to be at the same level. So minus 4, 2 यहाँ पर होगा. So minus 1, minus 2, minus 3, minus 4. Same level पे होगा. Minus 4, 2. इसको join कर दिया. ये horizontal line है. Y is equal to 2. जैसे देख रहे हैं, जो दिख रहा है शायद हो सकता है वैसा ही हो. So this seems like a right triangle. So let us look at the slope of this. Slope is 2 upon 1. इसका slope is 2 upon minus 4. That is minus half. So clearly m1, m2 minus 1 and this is right angle triangle. So right angle triangle, let's say call it A, B, C. क्या पूछा है? A is the area. So can I, okay, इसको PQR बोल देते हैं. A already दिया है question में, PQR. A is the area. So can I say area? या तो ऐसे निकाल लो या half base height. So half base is 5. Vertical height is 2. So A is clearly 5. What about B? B is the area of the circumcircle. So clearly this is the right triangle. तो भाई इसका hypotenuse यहाँ पर होगा. And इसका radius 5/2 होगा. ठीक है, तो hypotenuse का midpoint is equidistant from all the three vertices and this is actually the circumcenter also. तो ये 5 है, तो ये 5/2, तो radius clearly 5/2 है. B का value pi r square. That is 25 r square by 4. We have to calculate B by A, so this is very simple, very straightforward. 25 r square by 4 times 5. That is 5. Sorry, this is 25 pi by 4. 25 pi by 4 by pi. That is 5 pi by 4. So B upon A ratio is 5 pi by 4. This was again a very simple question and it could have been done in under 1 minute. 1 minute के कम टाइम पे ये किया जा चाहिए था. Okay, moving on. Question number 12. Value of sigma k varies from 0 to 202 minus 1 to the power k. It is this, not ratio. ये ratio नहीं है. So basically the question is this. The question is sigma k varies from 0 to 202 minus 1 to the power k 202 c k into cos k pi by 3. ये क्वेश्चन है. 202 c k cos k pi by 3. अब क्लियरली यहां पे क्वेश्चन के अंदर ही हिंट दिया हुआ है. क्वेश्चन के अंदर हिंट क्या है? फर्स्ट ऑफ ऑल यहां पे पावर नहीं है. हैड दिस बीन 202 c k x की पावर k, देन इट वुड हैव बीन 1 plus x to the power n or something like that. ठीक है. यहां पर cos k है. अब cos k मतलब पावर k था जो कि k बीच में आ गया, तो बहुत क्लियरली k जो है ना वो पावर होगी. और यहां पर यूलर फॉर्म लगी हुई है. यूलर फॉर्म, पोलर फॉर्म, जो भी रूप में, बिकॉज हमें पता है e to the power iota थीटा रेज टू द पावर k इज e to the power iota k थीटा. तो थीटा के साथ k मल्टीप्लाई होता है. तो यहां हमें पता है क्लियरली कि कहीं ना कहीं कॉम्प्लेक्स नंबर का यूज हुआ है. ठीक है. तो बेसिकली कुछ ऐसा होना था कि यहां पर cos पाई बाय 3 की पावर k होगी. cos पाई बाय 3 की पावर k होगी. एंड यहां पर देखो ऐसा भी नहीं है. देखो कभी कभी क्या होता है कि C0, C2, C4 ये चीजें चाहिए होती है कि C0 माइनस C2 प्लस C4 माइनस C6. ठीक है. तो ये चीज ध्यान दो. हैड द क्वेश्चन मीन C0 माइनस C2 प्लस C4 माइनस C6, then we use E1 plus iota something, 1 plus iota x, so that alternate terms are imaginary and every other term, ठीक है, एक छोड़ के जो टर्म है वो नेगेटिव साइंस के साथ है. अब यहां पर क्या है? C0 माइनस C1, so every C is there. ठीक है. इसका मतलब कुछ और है. तो यहां पर देखो क्या था? तो 1 प्लस e टू द पावर आयोटा पाई बाय 3 रेज टू द पावर n. इसको एक्सपैंड करते हैं. दिस इज nc0 प्लस nc1 e टू द पावर आयोटा पाई बाय 3 प्लस, ठीक है, इनफैक्ट यहां पे माइनस है तो यहां पर माइनस कर दो, बिकॉज ऑल्टरनेट टर्म्स आर माइनस. सो 1 माइनस, यहां पे माइनस आ जाएगा. प्लस C2 e टू द पावर आयोटा 2 पाई बाय 3 माइनस C3 e टू द पावर आयोटा 3 पाई बाय 3 एंड सो ऑन. सो क्लियरली गाइस यहां से अगर हम इस तरफ से रियल पार्ट उठाते हैं, रियल पार्ट, सो व्हाट इज गोइंग टू बी रियल पार्ट? बेसिकली यहां पर ये क्या बन जाएगा? cos पाई बाय 3 प्लस आयोटा साइन पाई बाय 3. ये क्या बन जाएगा? cos 2 पाई बाय 3 प्लस आयोटा साइन 2 पाई बाय 3. cos 3 पाई बाय 3 आयोटा साइन. तो अगर मैं रियल पार्ट उठा रहा हूं राइट साइड में, इट इज गोइंग टू बी C0 माइनस C1 cos पाई बाय 3 प्लस C2 cos 2 पाई बाय 3 माइनस C3 cos 3 पाई बाय 3 एंड सो ऑन. एग्जैक्टली व्हाट इज रिक्वायर्ड है. देखो ये चीज भी अगर तुम एक्सपैंड करोगे, C0 cos 0 पाई बाय 3 माइनस C1, ठीक है, ऑफ कोर्स n जो है वो 202 है. तो C0 cos 0 पाई बाय 3 माइनस C1 cos पाई बाय 3 प्लस C2 cos 2 पाई बाय 3 माइनस C3 cos 3 पाई बाय 3. तो राइट हैंड साइड आ गई. एग्जैक्टली सेम चीज. तो बेसिकली लेफ्ट हैंड साइड क्या है? मुझे रियल पार्ट ऑफ दिस निकालना है. So the question now becomes, I need to find real part of 1 minus e to the power iota pi by 3 raised to the power 202. This is the question. अब इसको मल्टीपल मेथड से कर सकते हो, यू कैन डू दिस यूजिंग अ लॉट ऑफ डिफरेंट मेथड्स. सो एक तरीका तो क्या होगा यार, वैल्यू ही लिख दो. ठीक है, लेट अस लुक एट 1 माइनस e टू द पावर आयोटा पाई बाय 3. सो दिस इज क्या बनेगा, 1 माइनस cos पाई बाय 3 विच इज 1 बाय 2 प्लस आयोटा रूट 3 बाय 2. सो दिस इज 1 बाय 2 माइनस आयोटा रूट 3 बाय 2. ये क्या बना, दिस बनेगा cos पाई बाय 3 माइनस आयोटा साइन पाई बाय 3. So this is actually e to the power minus iota pi by 3. e to the power minus iota pi by 3. ठीक है, तो मुझे क्या निकालना है, मुझे निकालना है रियल पार्ट ऑफ, तो ये चीज क्या बन गई है, तो रियल पार्ट ऑफ e to the power minus iota pi by 3 raised to the power 202. So real part of e to the power minus iota 202 pi by 3. ये एक्चुअली क्या बनता है, दिस इज cos 202 pi by 3 minus iota sine 202 pi by 3. So real part is clearly this, cos of 202 pi by 3, cos of 202 pi by 3, which is option D. Cos of 202 pi by 3, sorry, option C, cos of 202 pi by 3, which is option C. So C was the correct answer. The other way you could have done this was, दूसरे तरीके से क्या कर सकते हो, ठीक है, ये देखो, ये है 1 माइनस cos थीटा प्लस आयोटा साइन थीटा. ठीक है, इसकी पावर निकाल ली है. सो दिस इज 1 माइनस cos थीटा माइनस आयोटा साइन थीटा, एंड इसको तुम सिंप्लीफाई कर सकते हो. 1 माइनस cos थीटा इज 2 साइन स्क्वायर थीटा बाय 2 माइनस आयोटा 2 साइन थीटा बाय 2 cos थीटा बाय 2. तो 2 साइन थीटा बाय 2, इनफैक्ट थीटा यहां पर पाई बाय 3 है, थीटा पाई बाय 3 है, तो थीटा बाय 2 का वैल्यू पाई बाय 6 होगा. साइन थीटा बाय 2 हाफ होता है, 2 साइन थीटा बाय 2 1 है, तो 2 साइन थीटा बाय 2 1 है, तो बचेगा यहां पे क्या, आई विल बी लेफ्ट विद साइन थीटा बाय 2 माइनस आयोटा कॉस थीटा बाय 2. इसका पावर 202, इसका रियल पार्ट निकालना है. एक तरीका क्या है कि यहां से आयोटा से मल्टीप्लाई कर दो, तो कॉस थीटा माइनस आयोटा साइन थीटा की फॉर्म बन जाएगी, कॉस थीटा प्लस आयोटा साइन थीटा बन जाएगा, एंड यूलर फॉर्म लगा दो. अदरवाइज दूसरा तरीका तो ये कर ही दिया. सो सी इज गोइंग टू बी द राइट आंसर, दैट इज cos of 202 pi by 3. I hope this is clear to everyone.
Hi everyone, I am Surendra Jain, Master Teacher of Maths in Vedantu. I'll be solving further question number 11, which says for real numbers a, b, c, d, a dash, b dash, c dash, d dash, consider the system of equations ax square plus ay square plus bx plus cy plus d equal to 0, a dash x square plus a dash y square plus b dash x plus c dash y plus d dash is equal to 0. If S denotes the set of all real solutions x comma y of above system of equations, then number of elements in S can never be. Please notice both the equations are such that coefficients of x square and y square are same and there is no xy term, which means it can represent a circle. But if a and a dash are 0, then these equations can represent straight line also. In fact, imaginary circle, if it is, then there can be no locus at all also that can be represented by these equations. Okay, but in all scenarios you can see, if I draw two circles, okay, or I draw one circle, one straight line, or I draw two straight lines like this, you can see number of solutions could be 0, 1 or 2. Here two circles could be away from each other also, two circles can be touching each other also, so 0, 1 or 2. Similarly, if one circle, one straight line, then also we will be having either 0 number of solutions or 1 number of solutions or 2 number of solutions. So 0, 1, 2 are possible, 3 is never possible. In case of two straight lines, we can have 0 solutions or 1 solutions. Okay, so 3D will be the answer. 12. Let f comma g be continuous functions from 0 comma infinity to itself. Hx is given by this definite integral. Fx, capital Fx is also given by this integral. If f dash is a derivative of f, we have to find capital F dash. This question is direct application of Newton-Leibniz formula, which differentiate a functions given by definite integration, in which limits are variable. Here f dash will be differentiation of upper limit, that is h dash x, into we will be putting t as hx, so we will get this, minus differentiation of lower limit, that will be 0 only, and then putting t is equal to 0. Now there is no need to put it because this will be anyway 0, and this h dash x will be equal to differentiation of first integral, so that will be 3 power x into ln 3 into f of 3 power x minus 2 power x ln 2 and then f of 2 power x. So we need to put this h dash here. Okay, we will get the answer. I think the answer here is D. You can see g of hx is here, and other terms 3 power x ln 3 f of 3x minus 2 power x f of 2 power x ln 2. So this D has to be the answer. Okay, now coming to next question, we are given that suppose x and y are positive integers. If 4x plus 3y and 2x plus 4y are divisible by 7, then respective remainders are 2 and 5. If this 11x plus 5y is divided by 7, then the remainder equals. So here this 4x plus 3y will be of the form 7a plus 2. A is some integer. Okay, because it gives you remainder as 2. Similarly, this 2x plus 4y is 7b plus 5 because it gives remainder as 5. B is also some integer. Now if we add these two, you get 6x plus 7y is equal to 7 times a plus b plus 7. Now we can check that on left side and right side, these three terms are such which are multiple of 7. That means my 6x should also be multiple of 7. Multiple of 7. That means 7 divides 6x, but because 7 cannot divide 6, that means 7 will divide x. That means my x will be some 7 times c. It will be multiple of 7. Okay, now from these equation number 1 and equation number 2, you can see that this 3y has to be equal to, because 4x is already multiple of 7, so this 3y will be 7, let us say a dash plus 2, and this 4y will be 7b dash plus 5. If I subtract this first from second, so this y will be equal to 7 times b dash minus a dash plus 3. That means this y is actually 7 times, let us say d plus 3. That means if y divided by 7 will give us remainder as 3. D is also some integer. Now, if I am going to divide 11x plus 5y by 7, let us write this whatever we have obtained. X is 7c, so it will be 77c, c is integer, plus 5 into 7, so 35d, plus 5 into 3, 15. So you can see if we divide this thing by 7, this thing is divided by 7, I think remainder will be, because this will be completely divisible by 7, this will be completely divisible by 7, this when divided by 7 will give us remainder as 1. So answer here should be that B, 1 should be the answer. Coming to next question, suppose f R2R is a continuous function which has exactly one local maximum, then which of the following is true? Let us read options one by one. It says f cannot have a local minimum. It is having exactly one local maximum. It cannot have local minimum, but I think that is wrong, because for any cubic we know we have exactly one local maximum, one local minimum. So saying that it cannot have a local minimum is wrong. F must have exactly one local minimum. Please listen carefully. You may get a quadratic downward parabola like this, in which we will be having exactly one local maximum, but there is no local minimum. So saying that it has exactly one local minimum is also wrong. So this is wrong. This is also wrong. F must have at least two local minimum. This is also wrong from this example. Now coming to the option, F must have either a global maximum or a local minimum. Now if it is having one, if this function is having one local maximum, there can be two scenarios. Either this is having just this kind of diagram in which this is the only one maxima, or there's a possibility like cubic, Okay, or there is a possibility like biquadratic also, in which we will be getting one local maxima and we can have two local minimas like this. Okay, and because this function is defined for all real number, so and because function has to have maxima and minima alternate, so if this is point of local maxima, you can have at most 2 point of local minima like this. So saying this at least two local minima is wrong. In fact, it should have been at most two local minima. Then this C option would have been correct. But here, what we are having now, F must have either a global maximum like this scenario of quadratic or a local minimum. So local minimum will be there in this example like cubic also, or in the example like biquadratic also. Because if it is having one maxima, okay, and domain is all real number, it may have point of local minimas on the left side or right hand side or both. Or if it is not having point of minimas, then definitely this point will be the point of global maxima. So from this analysis, I think we can say that D has to be the answer. Okay, now coming to question number 15. Suppose Z belongs to complex number such that imaginary part of Z is non-zero. So Z is actually non-real complex number, and Z power 25 is 1. That means this Z will be actually 25th root of unity. 25th root of unity. And there is a property regarding this, that if Z is 25th root of unity, that is complex, non-real actually, non-real, then there is a property that 1 plus Z power 1 plus Z power 2 and so on up to Z power 24. Okay, that will be equal to 0. Now we are asked that what will be the summation k equal to 0 to 2023 Z raised to the power k. We may write this summation as Z power 0 plus Z power 1 and so on till it will go Z power 2023. Now here you can check that we are having total, because 0 is also there, 2024 number of terms. Okay, so 2024 number of terms. If I add one more term here, Z power 2024, and let us subtract this Z power 2024, you can see till this point I think we will be having 2024 plus 1, that is 2025 terms. Then I can make groups of 25 consecutive powers of Z, like Z power 0 till Z power 24. Then next would be Z power 25 till Z power I think 49. Okay, and so on. And the last one could be I think Z power 2000 and so on till Z power 2024. And as you all can see, I think it is not very difficult to observe that this will be 0, this will also be 0, because you may take Z power 25 common, then remaining thing will be 0, so multiplication will also be 0. Same way this will also be 0. So we are left with just minus of Z power 2024, whom I can write as minus Z power 2000 into Z power 24. 2000 being multiple of 25, so this will become 1. So answer here would be minus Z raised to the power 24, that is D. Okay. Coming to question number 16, we are given limit x approaches to 0, 1 upon x cos x plus cos 1 by x minus cos x cos 1 by x minus 1. I think we can write this as limit x approaches to 0. Cos x minus 1 if I combine these two. Okay, and if I take cos 1 by x common, here also this will come common, but here this will be 1 minus cos of 1 by x. Please notice these are actually the factors of this given thing upon x. Yeah, entire thing is divided by just x. Let me just check. Cos x plus cos 1 by x. Okay, and then minus cos x into cos 1 by x, then minus 1. Yeah, so this is how it will be. Now please notice that if this was x square here, so let me multiply by x here, then we will be getting this as some finite limit. In fact, that's a standard result, that we get this to be equal to minus 1 by 2. If it was 1 minus cos x upon x square, then it will be 1 minus 1 by 2. Then it is 1 minus cos of 1 by x into x. Now, as x will vary, x will approaches towards 0, 1 by x will approach towards infinity. As x approaches to 0, 1 by x will be approaching towards infinity or minus infinity, depending upon we are approaching towards 0 plus or 0 minus. But in all scenarios, cos 1 by x will be oscillating between minus 1 to 1. Okay, so this bracket here, this bracket which is 1 minus cos of 1 by x, that will be oscillating between, I think, 0 to 2. But 0 to 2, whatever it is going to be finite value. But here we are multiplying with x, that is approaching to 0. So 0 when multiplied with any finite number will give us limit as to be equal to 0. So answer for this will be A. This was really very nice question, because this is little confusing, because students start thinking that cos 1 upon x, because it is oscillating, so limit may not exist, but this is not correct. Answer here is definitely A. Okay. Now coming to next question, that is question number 17. Let n be a positive integer having 27 divisors including 1 and 9, which are denoted by d1, d2 and so on, d27, then product of this. See, there is one direct result on that product of all divisors including 1 and the number itself is always equal to that number n into number of divisors by 2. So here it is 27, so that will be n raised to the power 27 by 2. How it comes, let me tell you. See, if I arrange all the divisors d1, d2, d3 and so on, d25, d26, d27, okay, this is increasing order. So obviously this d1 will be 1 and d27 will be the number itself. So you can very easily notice that d1 into d27 will be equal to n. Likewise, this d2 and d26, they will be equal to n. Okay, d2 will be dividing n, d26 will also be dividing n, and this is second smallest and this is second largest divisor, so their product has to be equal to n, and so on. Here, because number of divisors are 27, so there will be one divisor in between, that is d14, which will be left out. It will actually be equal to under root of n. In fact, this number of divisors being odd number can be possible if and only if your number n is, perfect square. So this middle divisor has to be equal to root, and you can check for 4, which is a perfect square. The divisors are 1, 2 and 4. So the middle divisor is under root of that number. For any numbers you can check, like 36. 36 is 2 power 2 into 3 power 2. So number of divisors here would be 3 into 3, that is 9. So if you arrange the divisors like 1, 2, 3, I think next would be 4, and then I think it will be 6, not 6, just 1 minute. 6 should be the fifth divisor. Yeah, 6 is correct. Then it will be, I think, 9 here, then it will be 12 here, then it will be 18, then 36 here. So you can check for all such numbers, first into last, second into second last, and so on. They will give you the number itself. And if it is perfect square, then there will be one divisor that in the mid of all the divisors, it will be under root of that number. So here these 13 pairs will be complete, and the last number will be n power half. So the complete product here will become equal to n power 13.5. So answer will be C. Okay. Now coming to question number 18. F 0 comma infinity to r is a continuous function such that fx plus ln to 0 to x ft dt is equal to 1. Then for this. Okay. Now to do this question, first I'll do the differentiation, and then we can write f dash x plus ln 2 into, I think using Newton-Leibniz formula only, 1 into fx is equal to 0. Taking fx as y, I think we have dy upon dx is equal to minus ln2 into y. I think it's a very simple case of variable separable method. So we will get like this. So here it is, its integration will be ln y is equal to minus ln 2 into x plus c. Now you can see from this given relation, when x is equal to 0, this definite integration will become 0. So this fx or or y at x is equal to 0 will be equal to 1. So if we put it here, we will be getting 0 is equal to 0 plus c. So the value of c is 0. So the final answer for fx is equal to, let me first write y, ln y is equal to minus ln 2 into x. That will give you y is equal to 2 raised to the power minus x. So this fx is equal to 1 upon 2 whole raised to the power x. So answer is D. Coming to this 19th. This question is based on RF theorem, very famous thing in binomial theorem. This int x denotes largest integer less than or equal to x. Then we have to find the greatest integer or largest integer part of this 9 plus root 80 whole raised to the power 20. For that, what we do, 9 plus root 80 whole raised to the power 20. I will take one more expression, 9 minus root 80 whole raised to the power 20. Now notice that 9 is slightly bigger than root 80 because root 81 is 9. So this is a positive number. But definitely this 9 minus root 81, this 9 minus root 80 actually will be less than 1 and it will be greater than 0. Okay, root 80 is very much close to 9, so difference will definitely be lesser than 1. Now, what is the benefit of doing this? If you open it with binomial theorem, we get 20C0 into 9 power 20 plus 20C1 9 power 19 into root 80 plus 20C2 9 power 18 root 80 power 2 and so on. This is the expansion of first one. Now, if you expand the other one, I think the only difference here would be of alternate terms where there will be minus sign. Otherwise, all terms are same. Here it will be plus because the alternate terms are positive. Here it would have been minus root 80, but because it's a square, so you will be having positive sign, then it will be minus sign and so on. So if we add this, you can see this will be cancelled. Term after this will also be cancelled. All other terms will get added and we can write them directly 2 times integer because this 20C0, 20C2 all are integral values and 9 power 20, 9 power 18, then root 80 power 2, all even power of root 80 will make it integer. So this will always be integer here. Okay, so this is what we are getting. Now let us do one thing. Let us write 9 plus root 80 whole raised to the power 20 whole raised to the power 20 to be written as int of x, or let me write this as integral part I plus fractional part f. I is integral part as they are asking. So what we can say, then this I plus f plus this 9 minus root 80 raised to the power 20 will become even integer. Okay, here this f, that is fractional part, is from 0 to 1 and this is also between 0 to 1, strictly within 0 to 1. Now because I is integer and right side is also integer, so sum of f plus 9 minus root 80 raised to the power 20 must be integer only. Then only you can expect I plus some integer equal to even integer. Now because both of them are between 0 to 1, 0 to 1, so the sum can be just 1 only. You can see because this value will be from, you can check, 0 to 2. This is strictly positive, so it will be greater than 0, so sum has to be positive and the maximum possible value can be 2. And on 2 also you can see there is an open bracket because both of them cannot be 1 1 together. So within this 0 to 2 you can see the integer value will be just 1. Okay, so this f plus this thing has become 1, so the integral part this will be equal to this value minus 1. This is actually equal to 1. Okay, so here this integral part which we are looking for will be actually equal to 9 plus root 80 power 20 plus 9 minus root 80 power 20, which is equal to this even integer. Let me write it here only. 9 plus root 80 power 20 plus 9 minus root 80 power 20. So this I will be actually equal to this plus this minus 1. So answer will be, I think, C. Okay. Coming to the next question, question number 20. Let f R2R be a twice differentiable function, 1 to 1 function, twice differentiable 1 to 1 function. F2 is 2, F3 is minus 8, and 2 to 3, Fx dx is minus 3. Then we have to find minus 8 to 2 F inverse x equals. Now this question is based on that property that if you are given a to b Fx dx plus c to d F inverse x dx, where d is actually equal to f of b and this c is equal to f of a. This upper limit is value of b of function, c is value of function at a, then this becomes equal to bd minus ac. This is one important result that students remember. So based on that question, I think it is very easy. So you can see that 2 to 3 fx dx plus, now at 3 value of function is minus 8, so I'll put minus 8 here. At 2 value of function is 2, so f inverse x dx will be equal to 3 into minus 8 minus 24 minus 2 into 2 4, and this thing is actually equal to minus 3, so 2 to minus 8 f inverse x dx will become equal to minus 28 plus 3, that is minus 25. But here we are asked minus 8 to 2, not 2 to minus 8. So I think this minus sign will go away. So answer for minus 8 to 2 f inverse x dx will become equal to 25. So answer should be B. If you do not remember this property, I think then also this question can be done. Please see how. For this minus 8 to 2 f inverse x dx, I'll put x as, let us say, f of y. Okay, now when x will be equal to minus 8, when x will be equal to minus 8, you can see this y will be equal to 3 and x is equal to 2, then y will be equal to 2. Why it is so? Because it's a 1 function. So if x is equal to minus 8, and we know already when this fy is equal to minus 8, the y has to be 3 only, because it's a 1 function. There cannot be same value at two different numbers if it is 1. So this integration will become equal to minus 8 will convert to 3 and 2 will convert to, I think, 2 only. Okay, and f inverse of fy will be y. Okay, and dx will be equal to f dash y dy. Okay, now we will be doing integration by parts, taking this as second, this as first. We will be getting y into fy limit 2 to 3 minus 3 to 2, I think it is 3 to 2, not 2 to 3, 3 to 2, 3 to 2 here, and this will be first function ka differentiation and fy dy. Okay, so here if you put the values, y is 2, f2 is 2, okay, minus y3, fy is minus 8, so minus minus plus it will become 24. Okay, 2 into 2, 4 plus 24 minus, this is what we are given, that 2 to 3 integration is minus 3, so that will be plus 3. So here you can check also, we are getting 25 as the answer. So when very simple questions, this based on substitution you can say, or based on this property.
हेलो डियर स्टूडेंट्स। सो अभी हम क्वेश्चन 21 डिस्कस करने वाले हैं। तो ये परमुटेशन का क्वेश्चन था हमारे पास, जिसमें हमें 3 लेफ्ट ब्रैकेट्स और 3 राइट ब्रैकेट्स को अरेंज करना था। और कैसे अरेंज करना था कि अगर हम लेफ्ट से काउंट करें तो नंबर ऑफ राइट ब्रैकेट्स counted is always less than or equal to the number of left brackets counted, right? So if we represent left bracket by L and the right bracket by R, so we have 3L and 3R, right? और हमने इनको arrange करना है so that number of L must be more than number of R if we count it from the left. So definitely one L must be at the first place and one R must be at the last place. So now we have four positions that we have to fill using 2L and 2R. So if we see the arrangements of 2L and 2R, that is basically 4 factorial by 2 factorial 2 factorial, which is equal to 6. Now in these 6 cases, there is one case in which if we arrange like this, then the number of R are more than the number of L if we count it from the left. So we subtract that one case, that gives us a 5 as a number. So there are 5 such arrangements in which we can arrange 3L and 3R according to the given condition, right? So let's see the question number 22. So in the question number 22 is a limit based question. So we have the common thing here is 2 raised to power n. So if we assume 2 raised to power n is equal to t, so as n approaches to infinity, so t approaches to infinity, right? So what we have now then, limit t approaches to infinity. So in the bracket you will get, as we have minus 2 raised to power n plus 1, that will become minus 2n into 2, that is minus 2t, right? So we can say that it is 2 raised to power minus 2t, and in the second one again minus 2 raised to power n is t, so that is minus t, and 2 raised to power minus becomes 1 by 2, so 2 raised to power minus t by 2, and in the numerator we have 2 power minus n, so 2 power minus n is basically 1 by 2 power n, that is 1 by t. So now we have a limit in this form. So clearly we can take out common t raised to power minus 2 by t from the bracket. So what we get then, limit t approaches to infinity. So we take 2 raised to power minus t by 2 common. In the bracket we have plus t by 2 plus 1 and whole raised to power 1 by t, right? So now we can separate these two terms. So if we write 2 raised to power minus t by 2 into 1 by t, and the second thing is 2 raised to power, now if we simplify this we will get 2 raised to power minus 3t by 2 plus 1 raised to power 1 by t, where t approaches to infinity. So in the first one, if in the first one we have t get cancelled, right? So we have 2 raised to power minus 1 by 2, and in the second part if we see, if t approaches to infinity, then this term approaches to 0 because it is 2 raised to power minus infinity which approaches to 0, and this one 1 by infinity is also 0. So we have 1 raised to power 0, that is 1. So that is 1 by 2. So in question number 23, we have a quadrant of a circle in which we have drawn a full circle here, and CD is 10. So we have to find the area of the shaded part, right? So if we say the radius of this quadrant is r and the small circle radius is r, so we have to find out pi by 4 r square minus pi r square. So that we have to find out. Now let's see what is the relation between r, capital R, and this 10. So if we see, this height will be 2r, so we can say this OC length is also 2r, Now if we join OD, so now we have a right angle triangle here, so we can apply a Pythagoras theorem here, and OD is basically R, right? The value of OD is R. So if we apply OD square is equal to CD square plus OC square, so what we get from that, we will get 100 plus 4R square is equal to R square. Now let's try to make this expression from this one. So if we divide by 4, so we got this thing, right? Now multiply with pi, so 25 pi plus pi r square is equal to pi r square by 4. So 25 pi is equal to pi r square by 4 minus pi r square that we need. So the answer will be 25 pi. Right guys? Thank you. In question number 24, we have a function f from c to c, means complex number to complex number, where f is defined as f of a plus iota b is equal to e raised to power a cos b plus iota sin b. So we have checked for 1 1 and on 2. So if we go for first 1 1, if we see we have a cos and sine. As we know, cos and sine are periodic functions, so we can see that this function must not be 1 1. Like we have a value of cos of b plus 2 pi is same as cos b, and similarly sine of b plus 2 pi is equal to sine b. So we can see f of a plus iota b is same as f of a plus iota times b plus 2 pi. So clearly we can see the 2 points or 2 complex number for which we have a same value, so it cannot be 1 1. So it is not a 1 1 function. Now let's check for on 2. So for on 2 function, if we see f of a plus iota b is equal to e raised to power a, and the second form is cos b plus iota sin b is basically e raised to power iota b. So it is e raised to power a plus iota b, right? So if we see, can this expression take all complex values or all real values? If we see for the all real values, because in a complex number we have all real numbers also. So if I suppose b is equal to 0, so we got f a is equal to e raised to power a, and we know this is greater than 0, right? So clearly it cannot take all complex values because it cannot take all real values. So it is not in fact onto also. So neither 1 1 nor onto. So the answer of this is D. So let's move to the question number 25. So we have a function that is a non-decreasing function and is from integer to integer. So we have given two cases for the function, and we have to check for which it is necessary that fn is equal to n. So if we pick the first case in which f0 is 2 and f10 is 8. So if we just take the opposite, if we assume that fn is not equal to n, okay. So we have f0 is equal to 2, and what about f1? f1 can be 2 or more than 2. And what about f2? f2 cannot be 2, so it must be greater than equal to 3, right? Now for f3, as f3 cannot be 3 and f2 is already greater than equal to 3, so f3 is greater than equal to 4. And similarly if it goes on, so we have f of 10 is greater than equal to 11. So clearly this is not true, right? So there must be a number for which fn is equal to n. I hope ये clear होगा. So we assume that if fn is not equal to n, if we assume this, so clearly we cannot make a condition that if f0 is 2 and f10 is 8, right? Now if we see the second part, f0 is -2 and f10 is 12. So in this one we can take an example that if we take f0, f1, f of 9 is equal to -2 and f of 10 is 12, so it can easily follow all the condition of a function, that it is a non-decreasing, as well it is from integer to integer, and f0 is -2 and f10 is 12, right? So in this there is no necessary condition for fn is equal to n, but in the first one we have seen that if fn is not equal to n, so we got a contradiction. So the answer of this is in case 1 but not necessarily in case 2, right? Yes, let's see question number 26. So we have given a cubic polynomial where ABCD are real numbers, A is non-zero and fx is equal to 0 has exactly two distinct real solutions. If f dash x is a derivative of fx, then which of the following is a possible graph of f dash x? So as we have given that fx is equal to 0 has exactly two distinct real solutions. So this is possible only when we have one a repeated root and another is a single root. So the possibilities of fx are like this, right? Or so this is for a positive, and also you can draw a graph like this. So in all the possibilities you can see the derivative is positive as well as negative. So if you see the diagrams, in A it is only positive, in C it is only negative or 0, and in this one also it is negative. So the correct graph of this is B for f dash, because in this we have f dash is positive as well as negative. So we can easily observe this. So let's see the question number 27. So in question number 27, we have a quadratic where x belongs to R and fx lies between 0 to x minus 1 square for all x, and f3 is 2. Then what are the values of a, b and c? So the given fx lies between 0, means it is greater than equal to 0 and less than equal to x minus 1 square. So first if we make a graph of x minus 1 square, it is like this, right? So if we check for f1, f1 lies between 0 and 1 minus 1 square, which is 0. So clearly f1 is 0, right? And also for the remaining values it is greater than 0, because it lies 0 to x minus 1 square. So it means it x is equal to 1 is the vertex of the graph. So, or we can say x is equal to 1 is a repeated root, no? So that is the possibility. That is the only possibility, because fx lies between these two. So this is the point where it is 0. So for the remaining parts it is in question number 27. We have a function quadratic fx is equal to this, where fx lies between 0 to x minus 1 square for all x, and f3 is equal to 2, and we have to find a, b, c. So if we see here, and if I put x is equal to 1, we got f1 is between 0 and 1 minus 1 square, which is 0. So clearly f1 is equal to 0, and in fact this is the minimum value of this quadratic, and we know that there is only one point where the fx has a minimum value. So it means x is equal to 1 is a vertex of this quadratic, right? And also it is a 0 of this quadratic. It means it has a repeated roots, x is equal to 1 and 1. And the second thing, we know that f3 is equal to 2, right? So from these two we can find out a, b and c. So if we see, the sum of root is minus b by a, product of root is c by a, and f3 is 9a plus 3b plus c is equal to 2. So from the first one you will get b is equal to minus 2a. In the second one you get c is equal to 3a, c is equal to a. Now put in the third one, 9a plus 3b, b is minus 2a, so it is minus 6a plus a equal to 2. So from here you can find out a, that is 1 by 2. So a is 1 by 2 and b is minus 1 and c is 1 by 2. So the answer is A. Now let's move to question number 28. So we have to find that which factor is divides this polynomial, right? So if we try to find out the values of x or the roots of this polynomial, x power 10 plus x power 5 plus 1. So if you go for the integer roots, as the last term is 1 or the constant term is 1, so the only integer roots possible are 1 or minus 1. Clearly these are not satisfy this polynomial, right? Now there is one more thing. If you see the options, we have x square plus x plus 1, which has a factors omega and omega square, right? So let's go for omega and omega square. If I put x is omega in this case, so omega 10 plus omega 5 plus 1. So omega 10 is basically omega 9 into omega, and omega 5 is omega cube into omega square plus 1. So this is 1. So we got omega plus omega square plus 1, which is 0. So clearly omega is a root and omega square is also satisfies this one. So if omega and omega square are the roots, then these are the factors as well. So if these are the factors, so this gives x square plus x plus 1. So this is divisible by x square plus x plus 1. Now let's see the question number 29. In this one we have to find the locus of a midpoint of a line CD having length is 1. So CD length is given is 1, and we have to find the locus of a midpoint, and this angle is given theta, right? So let's try to find out the locus from the given condition. CD is 1. So if I say this angle is alpha, and we know the length of CD, and I have drawn a perpendicular from here, and let's say this is point M, right? So we can say the CM is equal to CD sine alpha. So as CD is 1, so CM becomes sine alpha. And what about MD? MD becomes CD cos alpha, which is cos alpha, right? So CM is sine. Now, as P is a midpoint of C and D, so let's try to find out the coordinates of C and D in terms of alpha. So to find the coordinate of D, we need this distance, right? Right now we got a length MD. So if we somehow got a length MO, then we can define OD. So OM you can find out from this triangle CMO. In triangle CMO, you can write OM by CM is equal to cot theta. So you will get OM is CM cot theta, that is sine alpha cot theta, right? So this is OM. So you will get OD, which is MD minus OM, which is equal to cos alpha minus sine alpha cot theta. So this is a OD, right? Now similarly you can, if you know the length OD, we can say the coordinate of D are, this is the x coordinate and the y coordinate will be 0. So cos alpha minus sin alpha cot theta, right? Now let's try to find out the coordinate of C. As this length CM is sin alpha, so y coordinate is definitely sin alpha. So we have to see the x coordinate. So x coordinate is basically minus of OM. So OM length we have already find out, sin alpha cot theta. So it is minus sin alpha cot theta. So this is the point C. So now we can use a midpoint formula, as the midpoint of CD is P. So I can say that 2h is equal to the x coordinate of C plus x coordinate of D. So x coordinate of C is minus sin alpha cot theta, and this one is plus cos alpha minus sin alpha cot theta, which is equal to cos alpha minus 2 sin alpha cot theta, and 2k will be equal to the sum of y coordinates. So this y coordinate is sin alpha plus 0. So 2k is sin alpha. Now we have to eliminate alpha, as we have assumed alpha here from our side. So we have to eliminate alpha. So we have two equations from which we have to eliminate alpha. So we can first put the value of sin alpha in the first equation. If I say this is 1, this is 2. So if I put sin alpha from 2 in 1, then I will get 2h is equal to cos alpha minus 4k cot theta. So ultimately cos alpha becomes 2h plus 4k cot theta, right? Now if we see this equation number 2 and 3, if we square and add these two equations 2 and 3, so we got sin square alpha plus cos square alpha is 1. So 1 is equal to sin square alpha is 4k square and cos square alpha is 2h plus 4k cot theta square. So this is the desired locus. So now we can replace k by y and x by h. So 4y square, now you can take, or if you open this expression you will get 4x square and 16k square cot square theta plus 16k cot theta. So you can take 4 common from the right side and take into a left hand side. So the expression that we get is the A, x square plus y square plus 4xy cot theta 16hk cot theta and plus 4y square cot square theta. Now let's see the question number 30. How many functions from 1 to 10 to 1 to 1000 which satisfy f plus I plus 1 minus fy is greater than equal to 20? So we have to pick 10 values from these, right, from 1 to 2000. So if we say we have 2000 places, right, corresponding to these 2000 numbers. Now from these we have to pick 10 numbers, and under this condition that fi plus 1 minus fi is greater than equal to 20, so I can say that f2 is greater than equal to 20 plus f1 and f3 is greater than equal to 20 plus f2 and so on, right? So we can say from here that the numbers between f1 and f2 must be 19, at least 19. if I say this is the value of f1 and this is the value of f2, then the numbers between these two numbers must be 19. Then f2 minus f1 becomes 20. So if I say that numbers between them is a1 and f2, f3, the numbers between f2 and f3 is a2, and the numbers before f1 is a0. So I can say that a0 plus a1, a2, and so on. So between f9 and f10 is a9, and after a10 it is a10. After f10 is a10. So how many numbers are these? As we have selected 10 numbers from 2000, so these are 1990 numbers, right? We have selected 10 numbers. Now it is again one more constraint is here, that a1, a2, a9 are greater than equal to 90, right? So we can replace a1 by a1 dash plus 19, and similarly a2 by a2 dash plus 19. So we get a0 plus a1 dash plus a2 dash a9 dash plus a10 is equal to 1990 minus 19 times 9. So what we get from here, 18, 19. So now we can apply a beggar coin method here. We have a 10 beggars and we have a coins 1819. So number of ways to distribute this is 1819 plus 10 minus 1, C 10 minus 1. So it is 1829 C, sorry, 18, how many terms are here? Sorry, 11 terms are here, right? So it will be 11. 1829 C 10 is our answer. So as we have to select 10 numbers, so these are the ways to do the selection. Thank you guys.